Okay, class, we're about to start section 7.5, dividing polynomials using long division and synthetic division. It says dividing by a monomial. If A, B, and C are monomials and B is non-zero, then A plus C over B is equal to A over B plus C over B. Now, I would just say this. When I was learning math, a lot of these symbols and the definitions really didn't mean a thing. So what I used to do is replace these symbols with numbers. So I'm going to replace these symbols with numbers so you can get a better idea of what this is talking about. So let's say we had 5 plus 3 over 2. This is saying that since both of these terms are divided by 2, you could separate it by doing this. This is what this actually means. Does everyone follow that? And in each case, you would still end up with 8 over 2, which is 4. So this is what this actually means. Now, you are to apply that here to example 1. We have 5x minus 15 over 25. So we can separate this. This would be 5x over 25 minus 15 over 25. But in this case here, we can simplify. 5 and 25 both has 5 in common, correct? So we know that 5 goes into 5 once, but since we have the x there, we would just leave the x, because it'll be 1 times x, which is x. And 5 goes into 25 5 times. So this would be x over 5. Minus 15 and 25 both have 5 in common, so that would leave us 3/5. So our final answer would be x over 5 minus 3/5. Does everyone follow that? Now, typically when you divide like this, typically you don't end up with the same denominator. This was an anomaly for these type of problems. But here, let's look at B. Now, B here, we're dividing again by a monomial. So we're going to separate this. This would be 18x to the 5th over negative 6x to the 3rd. Now, we know a positive divided by, well, we could just write that. So it'll be 5x to the 4th over a negative 6x cubed. And then it'll be minus 6x cubed over a negative 6x cubed. Now, let's do this. A positive 18 divided by negative 6 will give you negative 3. X to the 5th divided by x to the 3rd will give us x squared, because we will subtract these exponents. Now, we have a positive 5 divided by a negative 6, so we know this is going to have a minus sign to it. Now, what we would do next is this here. You notice here 5 and 6 has nothing in common, so we know we're going to have a fraction here. But x to the 4th divided by x to the 3rd will leave us x to the 1st, or just x. Now, if we look here, this is a negative 6 divided by a negative 6. We know this is going to be positive. So these two here, we have 6x cubed divided by 6x cubed, which will give us positive 1. And this is the final answer. Now we go here to C. C, we will separate this as well. We will have 6w to the 5th p over 6w squared p plus 12w to the 4th p squared all over 6w squared p plus 2w cubed p cubed all over 6w squared p. Now these 6's will simplify out to 1. W to the 5th divided by w squared will give you w to the 3rd. And these p's will simplify out to 1. And since we had w to the 3rd power here, we'll multiply by 1, which still will leave us w to the 3rd power. Now, both of these numbers are positive, so we know it's going to be a plus. 12 divided by 6 is 2. W to the 4th divided by w squared is w squared. P squared divided by p is just p. These two are positive, so we'll do plus. 2 and 6 both has 2 in common. But that would leave us 1/3. W cubed divided by W squared is W. P cubed divided by P is P squared. So this right here is the final answer.
Now, would it be okay if I put one in front of
Actually, okay, mathematically speaking, yes, that would be okay. However, because you have matured in math now, you should not put the 1 in front of the W. Just like, for instance, you all have experienced mathematical maturity because when you do problems, you don't say take away anymore when you do subtraction, right? Right. You do minus, subtract, and everything like that. But most times you do not find people at your level saying take away. So, let's take a look here. It says compare. We have 3x times this parenthesis here, which will give us 6x squared, and 3x times 5 will give us 15x. We learned this back in 7.1 through 7.3. So this is 6x squared plus 15x, doing the distributive property. Now, we would do this. We would add 6x squared divided by 2x minus 10x over 2x. 6 divided by 2 is 3. X squared divided by x is x. Minus 10 divided by 2 is 5. And the x's will simplify out. And we're done. Now, we go to the next page. It says, when we divide by a monomial, it is similar to using the distributive property. Dividing by a binomial is long division. And when they say using the distributive property, you notice how we took 3x and multiplied by both of these terms, right? We're distributing this 2x over the 6x squared and the minus 10x. That's what they mean by it's like using the distributive property. It's just using it with division. Now, we have long division. Now, I know a lot of you have gotten accustomed in some areas of just plugging this into your calculator. But we need to do this by hand because this is going to help us later. So 15 goes into 39 twice. 39 minus 30 is 9. And then you'll bring down the next digit. 15 goes into 98 6 times. 6 times 15 is 90. And 98 minus 90 is 8. And you'll bring down your 1. 15 goes into 81 5 times. 5 times 15 is 75. And you're left with 6. So our final answer, if we wrote this as a fraction, would be 265 6 over 15. Now, here's the problem with the 6 over 15. We can simplify 6 over 15 by dividing both by 3. So it'd be 265 and 2/5.
Would it be better to put 2/5 or like 0.4?
We don't want to do a decimal.
We don't want to do a decimal?
No. Okay. No. Because if that's the case, I could have just had you plug this in your calculator. Right. And the reason why we're doing it like this is it's going to be significant when we get to example 2. Okay, now, example 2. It says use long division to divide. Now, if you notice here, we have these 3 terms divided by these 2 terms, right? This is a quadratic expression a trinomial divided by a binomial. So what we would have to do is take x minus 2 on the outside and divide it into 5x squared minus 7x minus 6. Now, this is how you would go about dividing this binomial by the trinomial. Okay, so now, we would take this x, we would take the first term. We would ask ourselves, how many times does x go into 5x squared? How many times does x go in 5x squared? 5 what? Imagine if we were dividing 5x squared by x. If we have 5x squared divided by x, that would leave us 5x, right? So that means that x goes into 5x squared 5x times. And we line it up with the x value that's under the division bar. Okay, now, before we go on, are there any questions as to how I got the 5x? So everybody's good? Okay, I'll re-explain. The first thing you would do here, when you set this division problem up, you would take this first term of x and ask ourselves, how many times does x go into 5x squared? What you're basically asking, the number that you put up here, is actually what would divide, how many times does x divide into 5x squared, which we wrote here. So we have 5x squared divided by x, which leaves us a positive 5x. And we would line this up over the negative 7x because both of them have the same base of x. Does everyone follow that? Now, we have to do like we have done traditionally in division. We would take this 5x and multiply by both of these terms. What's 5x times x? It'll be 5x squared. And then 5x times a negative 2 will give us a minus 10x. Now, I want to ask you all something before we go to the next step. Let's go back here. Okay, now, when we did, let's just look here, forget about the 65 and all this other stuff. When we did 15 into 39, we wrote 2, right? Okay, what's 2 times 15? 30, right? Okay, why do we write minus 30? You say what?
Because we're subtracting.
Why? This is a positive times a positive. Why would we write minus 30?
Subtract it from the 39.
Okay, how did we get negative 30? How did we get negative 30? We multiply a positive 2 times a positive 15. How did we get a negative 30? Shouldn't that be positive 30? Where are you subtracting from? It just pulled out of thin air? Now I'm looking at all y'all faces, and I know people looking at this video got that look on their face too. I'm calling into question what you all have learned all these years.
You're subtracting the 30 from the 39. That's why it's
No, but where did the minus sign come from? Because positive 2 times 15 is 30 all day, right? Positive 30. So where did you all get this minus sign from? And wait a minute, what grade did you all learn how to divide in? Second, third grade? Are you smarter than the second or third grade? Yes.
Okay, so you get this, I'm guessing you get the subtract sign from, well, with divide, you're kind of like finding the multiple, I don't know.
Okay, listen. This is what happens. Remember, isn't division the opposite of multiplication? So every time we multiply here, because we are doing division, we have to take the opposite sign. So we're multiplying, and whatever we get from multiplying, we have to do its opposite. Does everyone follow that? So if this would have been a negative 2, when we multiply that, that would have been a positive 30, because we have to take its opposite, because we're doing division. Everybody follow that now, right? So you have been doing division right all these years. So let's scroll down here. Taking that knowledge that you just gained, we have to apply it here. We multiplied this. When we multiplied this here, it gave us this value. But because we are doing the opposite, we have to take the opposite side of both of these values. So this positive will become negative, this negative will become positive. So the 5x squares will simplify out to 0. Negative 7x plus 10x is 3x, and we'll bring down our minus 6.